Good morning students, this is Junita Mukherjee once again in SS Public School giving you the topics of very last chapter, that is semiconductor devices. And in the semiconductor electronic devices we have here one PN junction. How the PN junction is being created, let's see that one. Okay, so PN junction is symbolized as this particular thing is symbolized as PN junction. Here this is P-type impurities and these are the N-type semiconductor impurities. These are the p-n junction formation of the electron. Electron will drift to this particular side. Electronic diffusion is taking place in this particular side. So holes diffuse in this direction and the depletion layer is this particular area. It's called the depletion region here itself. So what happens to this p-n junction? How it is being created? Let's see this one in detail. So, in the junction arrangement by a close contact of the N-type semiconductors and P-type semiconductors, there are various methods of conforming P-N junction. In one method, an N-type semiconductor germanium crystal is cut into two slices called wafers, and aluminium film is laid on the N-type wafer, which is then heated in an oven at a temperature of about 600 degrees centigrade. Aluminium then diffuses into the surface of the wafer. In this way, the p-n junction is formed. Formation of the depletion layer in the p-n junction. In the N-type semiconductors, the concentration of the electrons is more than that of the holes. So, in N-type semiconductors, the concentration of the electrons will be more in comparison to that of the holes. Why? Because there is no hole, there is the sufficient amount of the electrons present in the N-type category. So, there is one extra electron which is free to move in this particular manner. So, in the particular manner it is being moving, and thus there are more number of electrons in comparison to that of holes itself. So, the holes is more than the electrons. So, p-type, in the p-type semiconductors, the holes are more than the electrons. During the electrons are more in electrons in more in N-type semiconductors, you know it very well. So P-type semiconductors have the concentration of the holes more than that of electrons. During the formation of p-n junction, due to the concentration of the gradient across p and n sides, holes diffuses to p side to n side and electrons diffuses from n side to p side, and the diffusion charge carriers combine with their counterpart in the immediate vicinity of the junction and neutralize each other. Thus, near the junction, positive charge is built and n side and negative charge is built on the p side. So, thus negative side diffusion takes place. Electronic diffusion takes place in the p side, towards the p side from n to p, and electron drifting is taking place at from position of p to n. Okay, as I have told you, thus it's a set of a potential difference across the junction, and the internal electric field EI directed to the n side to p side. The equilibrium is established when the electron EI becomes stronger enough to stop further diffusion of the majority charge carriers. However, it helps the majority charge carriers to diffuse across the junction. This region on either side of the junction will become the depletion free from the mobile charge carriers is called the depletion region or the depletion layer. The width of the depletion region in order of the 10 to the power minus 6 m. The potential difference developed across the depletion region is called the potential barrier. It depends on the dopant concentration in the semiconductors and the temperature of the junction itself. Semiconductor diode or p-n junction diode, it is basically the p-n junction with metallic contract provided by at the end of the application of the external voltage. It is two semi-terminal devices. It is represented by the symbol as I told you in the board. Okay, the direction of the arrow indicates the conventional direction of current here. So this is particularly the p-n junction diode when it is forming with each other, that is a doped semiconductor which is doped with some impurities. The word doped means it is containing some kind of impurities itself. Okay, so you are aware of this. Now this type of junction is forming in this particular area. Now P have the negative will acquire a negative charge, and N type will acquire a positive charge value. So thus this negative charge and positive charge have been acquired in the P and the N type semiconductors. Now forward bias and the reverse bias of the junction diode is being explained now. Now, biasing is a method of conventional connecting the external battery or EMF source of PN junction diode. The junction diode can be connected to the external battery of the two ways called the forward bias and the reverse bias of the junction. So, there are two types of biasing of the junction diode, forward and reverse. Now, the forward bias is being explained here. Forward bias, a junction diode is said to be forward bias when the positive terminal of the external battery is connected to the P side and negative terminal of the N side as a diode itself. So this thing is a forward bias itself. So why this forward bias? Because P is connected with the positive terminal and N is connected with the negative terminal of the battery. P for positive and N for negative. As it is there, it is in the forward bias. And this one is for the reverse bias condition. Why it is in reverse bias? Because P is connected with the negative value and the N is connected with that of the positive value of the battery itself, and this is what is called this reverse bias itself. Okay, now flow of the electric current in the forward bias. In this situation, the forward of voltage opposes the potential barrier due to which both the potential barriers and the width of the depletion layer decreases. Under the effect of the external electric field, holes in the P junction and the electron in the N region move towards the junction. The hole and the electrons mutually combine, thus near at the junction, and cease to exist. For each electron hole combination, a covalent bond breaks up into a P region near the positive charge, positive terminal of the battery. Out of the holes and electrons so produced, the holes will move towards the junction while the electron enters the positive terminal of the battery through the connecting wires. Thus, as the moment an electron is released from the negative terminal of the battery while enters the negative region of the negative region to replace the electron lost by combining with the hole at the junction. Thus, a current from the forward bias is constituted by the motion of the majority charge carrier across the junction. In forward bias, the junction diode offers low resistance. So, in this particular junction wire, this current is more, but resistance will be low in comparison to that of the reverse bias case. Okay, so it is moving towards this particular area. This is the junction area. This is moving towards the junction area. These all will move and combine with each other. That is, the holes in the N region and the P region will combine with each other, and thus the junction and it moves from this area from positive to negative terminal of the battery itself, and thus the forward bias condition takes place, and thus the current will move from positive to the negative terminal of the battery itself, and thus the forward bias condition takes place. Reverse biasing, a junction is said to be in the reverse bias when the positive terminal of the external battery is connected to the N side and the negative terminal of the is connected to the P side of the diode. Flow of current is reverse bias. In this situation, the reverse voltage supports the potential barrier, due to which both the potential barrier and width of the depletion layer increases. Under the effect of the external field holes in the P region, electrons in the N region pushes away from the junction. They cannot be combined at the junction, so there is almost no flow of current due to the majority charge carriers. So here the majority charge carriers are the electrons in here, and electrons are the majority charge carriers here. So under the effect of the external electric field, holes are the P region, electrons are in the N region. They cannot combine with the junction, and there is almost no flow of electrons due to the majority charge carriers. So electrons are the majority charge carriers here, and holes are the minority charge carriers. Wait for a while. So this flow of so this is no important no current flow is in the majority charge carrier. So here minority and majority charge carriers are here, as I told you. The small very small current due to the minority charge carriers flow across the current, and the current is called the reverse bias itself. So minority charge carriers are here flows across the junction itself. Okay, and thus this will move towards in this particular area. The current will move, but it's very feasible amount, a small amount of current is moving in the reverse bias condition itself. So minority and majority charge carriers, you know about it, how it is being moving, you know it very well. What are the minority charge carriers, how the minority charge carriers are moving, and how the majority charge carriers are moving. As I have discussed here, so the equilibrium in the field has been discussed and strong enough to further. Now I will just explain about the IV character voltage characteristics of PN junction diode. Okay, in this particular IV characteristics, I will explain to you once. First, this is forward voltage and this is the forward current itself. In this particular option, the voltage is positive, that is point 0.3 here, and in that particular point 0.3 there is a rise in the current. Okay, point 0.3. But in this particular region we have a negative charge carrier, and thus we will have negative reverse bias, that is in the negative proportion. At the value -10, it is being abruptly increasing in the reversed current is abruptly increasing at -10, 1, 0, 1, -2, -3. In this condition it is being neglected, or very small amount of current is being moved, and at -10 position breakdown voltage is being taken up, and this is called the reverse bias condition. In this biasing we will have this PN junction connected with the voltmeter of the positive terminal and negative terminal at the end region. It is connected with that of the micrometer, and then the rheostat, and then the battery itself is connected here. This is in the forward bias condition. P is connected with the P and N is connected with that of N. Okay, but in the case of this for reverse bias condition, P is connected with the negative terminal and N is connected with that of the positive terminal, and P is connected with the positive terminal of mu A, and negative terminal of this voltmeter will be connected with that of the rheostat, and that with the battery and so on. This is the reverse bias condition. Okay, so forward bias condition, the current diagram has studied the forward bias characteristics is shown in the figure. Starting from a low value, forward bias voltage is increased setup, and the forward bias is noted at diameter. The graph is plotted between voltage and current, and thus it has been shown at the start when the applied voltage is low, the current through the diode is almost zero. It is because of the potential barrier which opposes the applied voltage. Till the applied voltage exceeds the potential barrier, the current increases very slowly with increase in applied voltage OA proportion to the graph. With other increase in the applied voltage, the current increases very rapidly. In this situation, the diode becomes like a conductor, and the voltage beyond the current through the junction starts increasing rapidly with the voltage in the knee voltage or threshold voltage, where AB is extended back. It cuts the voltage axis at potential barrier voltage. Reverse bias condition, the applied voltage supports the flow of the minority charge carriers called the across the junction. So very small amount of current flows through the junction due to the minority charge carriers motion of the motion minority charge carrier is also propelled by internal potential barriers. So the minority charge carriers cross the junction, and thus therefore the small reverse current remains almost constant over a sufficient long range of reverse bias, increasing with that of increasing voltage. This reverse current is voltage independent up to certain voltage known as a breakdown voltage, and its voltage depends current is called the reverse situation current itself. Next, I will explain about the diode as a rectifier and a full wave and a short full wave and half wave rectifier, which will be I will explaining in the next video. Till then, take care and please study well about this, which is very important topic which I have explained to you in this particular minority charge carrier and majority charge carriers as holes and electrons. So please go through this particularly very well, which will be very important topic of this particular chapter. Thank you.